Alright, so here are some extension notes for the cell unit, and really what I'm going to focus on in this episode is the first three targets, 2.1.1 through 2.1.3, because there's quite a bit of material here that I want to supplement with your reading notes, but this is material that you'll need in addition to your reading notes and what we do in class to be successful on the assessment. So it's very important that you watch this and add this information to your notes. So let's go ahead and get started talking about the cell theory. So really what we need to do here is make sure that we understand what the tenets of the cell theory are. And I'm not going to write them here because you have them in your reading notes and they should already be in your notes. But what's important to know is that according to some people, there's an additional tenet of the cell theory. Now, IB wants you to only be aware of three, but I'm giving you this as a piece of extension knowledge that will come in handy in the future and will help us make some connections to other material. And that additional tenet is that all cells contain genetic material or information in the form of that all-important molecule DNA. Now remember that DNA gets passed from parent to daughter cell. Something similar happens in sexual reproduction, but we haven't talked about excuse me, those mechanisms yet. But that's really what's happening. Remember that DNA gets passed down via DNA replication. Remember, the DNA gets copied using helicase and DNA polymerase, and then it gets split into two daughter cells. So each cell gets the same copy, but that the real purpose of that DNA is the transcription, to be read for transcription, and then that same message be read in translation for protein synthesis. That's what transcription and translation are about, or trait expression sometimes. And really this is a big connection back to our evolution unit. Those individuals that have a genetic trait, basically coming back to DNA, and are more likely to survive and out-reproduce or are more fit in their environment than other individuals, are going to pass on more traits. That in itself is evolution. That's the definition that we discussed. Okay? So let's move on to some evidence, but this idea should supplement what you already have in your reading notes. So let's talk a little bit about evidence. I'm going to switch to a different color here. So evidence of, this is evidence for the cell theory. So let's talk about the first tenet that we wrote down. Sorry, you wrote down. And that first one is that all living things are made of cells. Well, at least one cell. Some things are just one cell. Well, let's talk about the evidence for that claim, because that is quite important to discuss. So, and that's what you need to be familiar with. Now, you also need to be familiar with the scientists who did their work here, but the evidence here is that since Hooke, there have been huge numbers of studies done on tissue samples, all of which have been found to be made of cells. So we have lots and lots of evidence to support this claim because we've seen it in lots of tissue samples. The next claim of the cell theory, the next tenet, is that the cell is the smallest unit of life. Well, the evidence for this is that what can be done experimentally is a cell can be broken, and then the subunits, or the parts that make it up, are separated through a centrifuge, but these subunits don't survive for very long. They die off. They can't replicate on their own, and so therefore they're not surviving. Alright, so in the limited amount of space I have below, I'm going to write the third one. So all cells come from other cells. And really this is done two ways. We know this from two different things. We've got experiments and observations. And experimentally we know that if cells are killed, say if cells are killed, cells don't regenerate from non-living material. The observations that we see is that when we see cells or tissues growing, we see cells separating or splitting, not new cells from non-living material. Okay? Now that leads me to a couple of questions I want to ask you about this. So these are some extension questions that I think that would be important for us to consider. And the first, and this is a really what we call nature of science. You might see some connections. Those of you in TOK, you might see some connections there as well. So I'm just going to jot these down and read them at the same time. So why is it not possible? Why is it not possible to prove, I'm going to underline the word prove, that all living organisms consist of cells? However, sorry about that, however many tissues have been examined. So why is it that we can't ever prove that all living organisms are made of cells, no matter how many we look at how many tissues we look at in the future? Okay, I think that makes sense. So think about that. Maybe you have an answer for that. And think a little bit about what the definition of theory is and how we defined it earlier in the year. Secondly, if scientists found life on another planet in the universe, I guess it doesn't have to be in the universe, let's just define it that way, and the organisms are made of cells, does this prove that all organisms are made of cells? And third big question I have for you is, the statement that all cells come from other pre-existing cells implies that life has always existed. Is this possible? Or if it is impossible, must we discard or throw away this part of the theory? In essence, all cells come from other cells implies that there's always some previous cell. So where does that first cell come from? Well, if we keep going back, it implies that there's always a cell. That's not part of the question. But does that mean that we must discard this part of the theory? All right, in the last section I wanted to very, very quickly discuss is this idea of multicellular organisms versus unicellular. Now, your book discusses several things that all living things have to be able to do. You can equate them very easily to the characteristics of life that you might have learned in Bio 1. We've got multicellular versus unicellular, and the question that I want to ask you that the book does not discuss is which is more complex? Which one is more complex? You might very quickly go to multicellular because there are more of them and they have to work together in different ways. But let me remind you that in order to survive, all cells, or all living things rather, all organisms have to meet the same requirements. If we think about it from that perspective, that means that unicellular organisms, well, let's think about multicellular. I guess let's think about ourselves first. Not to be selfish, but multicellular organisms have cell specialization, which means that we have cells that do different things. They specialize in different jobs. And really what that means is that only some cells do some things. We don't have any cells that do it all. But that's not the case for unicellular organisms. They're made of one cell, so their cell can do it all. When I say do it all, I'm talking about all those things that the book discusses as requirements for life. Okay? And that wraps up the first episode.